Hello everyone, myself Sanjana and today we'll be talking about psychological big data analytics inferring human emotions from massive social media data. And today we'll be discussing this research paper. Coming to the problem statement, it is the proliferation of AI generated images. AI generated images, especially through GANs, are becoming highly realistic and often indistinguishable from real images. As these AI generated images spread across digital platforms, there is a growing challenge to automatically detect and classify them. Existing image classification techniques often struggle with accurately distinguishing AI generated images from real ones, especially as AI models evolve. Current limitation: existing image classification techniques often struggle with accurately distinguishing AI generated images from real ones, especially through AI model evolve. Need for automation: manual detection is inefficient and prone to errors, necessitating the development of automated systems using deep learning models like CNN. The aim is to develop a reliable CNN based model that can accurately detect images from real images, addressing this emergency issue in the digital space. Coming to introduction, increased use of AI generated creation. AI technologies, especially generated adversarial networks, are being used to create highly realistic images, blurring line between real and AI generated images. So AI generated images are becoming difficult to distinguish from real images, creating challenges in various fields like media, entertainment, and security. And importance of image authentication: as AI generated images are becoming more prevalent, there is a growing need to develop tools that can authenticate whether an image is real or artificially generated. Convolutional neural networks are powerful deep learning models used for image recognition tasks, making them suitable for detecting AI generated images. Project objective: the project aims to build a CNN-based model to classify images as real using scientific dataset and advanced techniques like NetSet and for accurate detection. This was about the introduction. Next we have objective. Develop a CNN-based model. Build a convolutional neural network to classify images as either real or AI generated. Utilize a scientific dataset. Leverage that sci-fi dataset containing 120,000 images, 60,000 real images, and 6,000 AI generated images for training and testing the model. Employ ResNet architecture. Use the ResNet model to improve feature extraction and handle the complexity of image classification. Optimize model performance. Tune parameters like batch size, learning rate, and optimize it to enhance accuracy and minimize errors in classification. Next, we have deploy. Next, we have deploy the model. Create a web based application to deploy the trained model, allowing a play upload images and classify them as real or AI generated images. This was all about the objective: developing a CNN based, utilize the SciTech dataset, employ ResNet architecture, optimize model performance, and deploy the model. Next, we have dataset, SciFic dataset. The dataset set used in this project is SciFic, which consists of 120,000 images. Image composition: 6,000 real images and 60,000 AI generated images. Image type: the dataset contains a variety of image types and categories, offering a balanced representation of both real and AI generated images. Data split: validation set, that is used to train the CNN model. Then we have the validation set used to fine tune the model and avoiding overfitting. Next we have used to evaluate model performance on unseen data preprocessing, resizing images to a fixed input size suitable for CNN, normalization to scale pixel values between 0 and 1, augmentation techniques like rotation and flipping to enhance model robustness, Then we have the CNN architecture, input layer, computational layer, Leo activation, pooling layers, max pooling, fully collected layers, dropout layer, output layer, and software optimization. These are the some points that we will discuss. Input layer accepts input images. Convolutional layers apply multiple filters to extract features like edges, textures, and patterns. Use ReLU activation for each convolutional to introduce law of linearity. Pooling layers, max pooling to reduce spatial dimensions while retaining important features, helps in reducing computational complexity and preventing overfitting. Fully connected layers connects the high-level features on the convolutional layer to output classes. Dense layers process the flattened features to make final predictions. Dropout layer regularization techniques to prevent overfitting by randomly disabling some neurons during activation. Output layer softmax activation for classification, outputting probabilities for real or AI generated images. Next, we have the challenges. In challenges, we have real high realism of AI generated images, overfitting, imbalanced data handling, and computational resource demand. That is the hyperparameter tuning. AI generated images are becoming increasingly distinguishable from real, making classification harder. Overfit, due to large dataset and complex architecture, the model risks overfitting, especially during training of limited categories. Imbalanced data handling. Although the Cyphic dataset is balanced in real world scenario, there might be an imbalance in real versus AI generated images, requiring strategies like data augmentation for resampling, computational resource demand, training. CNN models like ResNet requires high computational power and GPU resources for efficient finding optimal values for finding optimal values for parameter like learning rate and numbers of echoes during time consuming and challenging. Next, we have deployment, that is the application framework, model integration, funded interface, cloud hosting. All these are the part of the deployment. That is how we deploy. Deploy a train CNN model into a web-based application for user-friendly interaction. Allow users to upload images and classify them as real or AI generated. Use Flask or Django for backend development, TensorFlow Keras for serving the train model, model integration, integrate the train model web app using TensorFlow serving or Flask API for seamless image classification. Conclusion. That is a successful AI image classification that the project demonstrates the effectiveness of CNN, particularly ResNet 50 in distinguishing between real and AI generated images. Model performance. The trained model achieved high accuracy in classifying image from the Cyphic datasets, showing its capability in handling complex image features. Automated detection of AI-generated images essential in fields like media verification, security, and content moderation. The model can be enhanced by incorporation of more sophisticated architectures, larger datasets, and real-time applications. Deployment feasibility. The model's successful deployment via web applications showed for practical use, allowing users to classify images easily. Thank you so much for watching.